these two. So let's look at question 5. And this is your homework. I picked this one because it talks about contradiction, identity, and a conditional equation. Now let's review the differences here. Conditional. What's conditional mean? You get an answer. All right, if you solve it and you get an answer, it's conditional. Identity. What does that mean? Sides are the same. Completely the same. Contradiction. What does that mean? False statement. Doesn't work. So let's look at question 5 here. We've got 3 times x minus 8 plus 5x. Now they use parentheses, but we really don't need them there. And then we've got 8 times x plus 8 minus 5. Pretty simple on this one. What do we need to do? Order of operations. Parentheses go first, so distribute and distribute. These parentheses around the 5x really aren't needed. And sometimes they add in extra things that aren't needed. So we're going to distribute that 3 through. So that's 3x minus 3 times 8. That's a 24. Keep your sign. We don't need the parentheses. We'll put the 5x there. On the other side, we have 8x. And we've got 8 times 8. Well, 8 times 8, that makes it a 64 minus 5, right? Okay. Now, when we combine these together, what do we have on the left? 3x, 5x makes it 8x minus that 24. What about the other side? 8x and 64 minus 5. So 64 minus 5, that makes it a 59, doesn't it? Now, what's going to happen when I move that x over? When I move that 8x over, what happens to it now? Okay, those go away, and so we are left with a negative 24 equals 59. And I picked this one just to review the 3 types. Conditional, you get an answer. Contradiction, no solution. False statement. Identity, the same. Well, these aren't the same, are they? I don't get a number. Does minus 24 equal 59? No. So this is false. So this would be a contradiction. No solution. And that's what I want to see. Contradiction. No solution on that. I picked that one as a nice review. We don't work with contradictions very often, but we need to know what they are. Okay? Contradiction is just a false statement. Question 9. Very simple one here. This one I picked because of the fractions. Can someone tell me what technique I would use to clear the fractions? Yep, someone said it. Cross multiply, right? So we have a fraction equaling another fraction. So what do? Cross multiply, just like that. And when I cross multiply, we use parentheses. So we have 6 times x plus 9 equals 2 times x minus 1. Okay. Now we can finish it. Now it's easy. Hard part's over. I just wanted to make sure we completely understand how to clear fractions. So distribute through, and that is 6x plus 54 equals 2x minus 2. Make sure you distribute through. And this is college algebra, so we can do things in one step. So I'm going to move the 2x over and move the 54 over as well. So we can do several things at once. 6x minus 2x, that makes it a 4x. 54s are gone. 2x's are gone. These go together, and that makes it a negative 56, doesn't it? When we add, right? They're both negative, put them together. And now what do? Divide by our 4. And that leaves me with now a positive or a negative number. Which one? Negative, right? So it's going to be a negative 14. Where are students most likely to make a mistake? Now, we know how to solve this. Most of us should have no trouble solving it. Where students make a mistake and get frustrated is we do simple mistakes. Like, for example, one of the most commonly made mistakes is somebody will forget to take this 2 and multiply it by the negative 1. I see it happen all the time. That's why I draw the arrows, so I remember. I know it looks kind of childish to do that, but I draw the arrows so I remember it goes through each part. Because I'm afraid if I don't draw the arrows, I might forget that 2 goes through each piece. So take your time, draw your arrows if you need to. I think you should. That way you remember that it goes through each part and you don't make a mistake. That's the frustrating part, is when you know how to solve it, but your answers aren't correct because of simple little mistakes. We know how to solve these, but we make mistakes. We all do. Try to make as few of those as possible. Draw arrows if you need to. Take your time. Use a calculator. If in doubt, use a calculator. I would rather use a calculator than make a mistake. So if you're not good at mental math, use a calculator. I don't have a problem with that at all. I would rather you do that than make a mistake. Did we have any others now to look at out of 1-1? Anything else out of 1-1? Sure. Sure. Yep, we can look at one of those. Okay. I think last time we went over, if I remember right, I can't remember which one we did. I think we did 14. We'll look at 15. Okay, so you can do 14. I think I did it last time in class, but we'll look at 15. I did one of them. I can't remember which one. But yeah, we did 14 in class, so we'll do 15. If you want to see how to do 14, go back and look at the notes. So what we're going to talk about in this question is we're going to talk about simple interest. Okay? Now, when we go to the bank and take out a loan or reinvest, we have 3 things. We have how much money we put in there. That's the amount. That's called the principal. We have a percentage rate that it pays out. Okay? And then we have how much money we made in interest. And our formula is this. Our formula is I equals P RT. And P is going to be the principal, or the starting amount. Then we have R. R is the percentage rate, but this has to be as a decimal. And then we have time. Now here's the most commonly made mistake is time. Time is in years. So if it's in months, you're going to have to divide it by 12. Right? Because time has to be in terms of years, not months. If it's in quarters, you're going to divide it by 4. I is what we want to find. So let's go through now, read it, and answer the question. Sophia borrowed $10,152 at 4% interest for 3 months. How much will the interest amount to, and what is the total amount that she will have to pay back at the end of 3 months? Okay, so we have to be very careful with the T. So let's think about what we've got. We're going to identify the parts. The principal. How much money did I borrow? All right, I borrowed $10,152. That's what I borrowed. I borrowed it at a rate of 4%, and 4% as a decimal would be 0.04. Make sure it's in a decimal form. Now T. Here's where students make a mistake. T. I am not going to use a 3, am I? No. 3 is months. We want it in terms of years. So 3 months, we're going to divide that by 12 because there are 12 months in a year. And let's go ahead and reduce this. And this is going to reduce down to now be 1/4. Do not use that 3 because we're not taking this loan out for 3 years. We're taking it out for 3 months. That's where students make a mistake. Now, you could convert this to a decimal. I'm going to leave it as a fraction. And we'll multiply, and I like to divide at the end. So let's go ahead now and work this out. So I equals, we've got 10,152, that's my principal, times 0.04 percentage rate, and we're going to multiply that by 1/4. And we'll just put all of this over 1, and then we'll just multiply all the tops together. So you take the numerators here and multiply them all together. So let's see what we've got. We've got 10,152. We're going to multiply that by our 4%, and then we're going to multiply that by 1. So that gives you 406.08, and 1 times 4 is still a 4. And we'll divide that now by my 4, and we're going to round if we need to the nearest cent. In this case, we don't need to, so it's going to come out to be $101.52. Now, what are the answers? We have to make sure we get both of these because it says, how much am I going to have to pay back, and what is the interest? Okay, so let's make sure we label. The interest is $101.52, and my total is going to be $101.52 plus the original $10,152, and so my total, when I add these together, gives me now a total of $10,253.52. So I'll go ahead and label these so we know where they're at. This is my interest right here, $101.52. Add them together. So at the end of 3 months, I've got to pay back $10,253.52. Okay, is everyone okay with how I did that one now? Right? And so that was 15. You can do 14 on your own. Very similar though. Different numbers. That's it. Okay, any others out of 1-1 to look at? Do I take care of those? Okay, well, if not, then we'll go ahead and start 1-2. And 1-2 is applications. You've seen these applications before in previous courses. However, students always struggle with them. You've seen these type of problems many, many times before, but we still have to make sure we know how to do them. So we're going to be looking at the mixture, the investment, and the distance questions. And so I'm going to pick these out of our textbook. And before we do the mixture, investment, and distance questions, we're going to start off with some geometric figure ones first. We'll just probably do one of those. Students don't struggle with these as much as they do the mixture and investments. So let's just do one of these. Let's look at, they're all pretty similar. How about we look at question 15? And this is on page 119. So page 119, question 15. If you have your textbook, that's fine. If you don't, it's up on the screen. So if you don't want to dig out your textbook, that's fine. I'll put it up on the screen. Now what we're going to do is we're going to read the question. Then we're going to think about what we need. We're going to come up with our formulas. And then we're going to read it again and put the pieces into the formula and solve it. Whenever you need a formula, where do we go? Whenever you need a formula, back cover of your textbook. Okay, so anytime you need a formula, go to the back cover. All right, so let's look now at question 15, I believe. Yep, that's what I said. I think I said 15, didn't I? Yep, 15. So question 15, we're going to talk about perimeter. So perimeter of a plot of land. We're going to read it. We're going to see what we've got and solve it. We're not going to put units of measure on until the very end. So the feet we don't use until the very, very end. So let's read it once and kind of get an idea of what we've got. The perimeter of a triangular plot of land is 2,400 feet. Okay. The longest side is 200 feet less than twice the shortest side. The middle side is 200 feet less than the longest side. Find the lengths of the three sides of the triangular plot. So, what do we know first? We know this is a perimeter problem. Perimeter is always the same. It doesn't matter what figure it is. Perimeter, by definition, is adding up all the sides. It can be a rectangle, a triangle, a square, a parallelogram. It doesn't matter. When I say perimeter, what does that mean? Add up all the sides. You can look up the formula, but I just remember that perimeter is the sum of all the sides. So perimeter is going to be the sum of all the sides. And they tell us, in this case, that our perimeter is what? It's that first part that we come across. And that perimeter is, if we read it, that's going to be that 2,400. Is everyone okay with that so far? So, again, let's put it up on the screen. Perimeter, 2,400. So we went through and we labeled it. What I always like to do is read it through once and then look back at it in small pieces. So we did the 2,400. Now, what do we also know about the perimeter? It's the sum of the sides, okay? And this is a triangle, so how many sides do I have? Triangle has the three sides, right? Now, what do we know about the sides? They're all different, we assume. So we have a short side, middle side, and the longest side. And that's going to equal our 2,400. Now, I like to use words to represent things, and we'll plug in the variable x in a moment. But right now, we're just coming up with our equation. So we're slowly building it. We got the perimeter. We labeled that. We know it's all three sides. So the short side, middle side, and the longest side, they add together. And they give us the 2,400. Now, how do they relate to each other? So now is where we have to use the variable x. So now we're going to have to move on past that 2,400 and we're going to have to start reading again. So longest side is 200 feet less than twice the shortest side. So longest side, 200 feet less than twice the shortest. So that's going to be 2 times the short side minus 200. Is everyone okay with how I did that? I did in terms of words. I think it's easier to do words and then put the variable in. So longest side is 2 times the shortest side minus that 200. The middle side is 200 feet less than the longest. So the middle side is going to be the longest side minus 200. Okay, so we have that. And one of these we know nothing about. Which one of these do we know nothing about? The short side, right? So the short side we know nothing about. So that means that short side is going to be x. Now we need to make sure everything gets an x. So we're going to rewrite it in terms of the variable x. So the short side will stay the same. Short side is still the x. The middle side we're going to come back to. The longest side, though, we're going to rewrite it. And the longest side is the short side doubled, right? Twice the short side, so that's doubled there, minus the 200. Well, the short side is x, so the longest side would be 2x minus 200, right? Okay, very easy there. Again, I like words. I think it makes it a lot easier. Now be careful with the middle side, because the middle side is the longest side, so that's 2x minus 200 minus another 200, right? Because this is the long side right here. And when we put that together, that is going to be 2x minus 400, right? Move this so we can see it all. Is everyone okay with the middle side now, right? Longest side minus 200. Longest side is 2x minus 200. So put those together, and that gives you that minus 400. Now we can build our equation and work it out. I have not put feet on here at all yet, have I? No. Units of measure, we put on at the end. It's confusing if you put them anywhere else, so put them on at the very, very end. So now let's look at our equation. So our equation for the perimeter is the short side plus the middle again plus the longest side. And that equals your 2,400. Well, we know the short side is x. The middle side is 2x minus 400. And the longest side is 2x minus 200. And that equals our 2,400. Now we should be able to quickly and easily solve it. We've got our equation. Hard part's done. Once you get the equation, students usually don't struggle with solving them. It's just getting to that point. Combine like terms. So total number of x's is going to be 5x. And then we've got minus 400, minus 200. So that is going to now be minus 600 equals your 2,400. Add on your 600. And now we've got 5x equals the 3,000. Okay, and divide by our 5. And that gives us, I believe, 600. 600. Right, so what do we want? Let's make sure we answer the question here. We want the lengths of the three sides of the triangular plot. So we want all three. Okay, so we want to find all of our sides. So we found our x here. Okay, x was, that's 600. So the short side, well, that is x. So the short side is 600. And now we're at the end. So we're going to label it with our units. So the short side is now 600 feet. And what about the middle? Well, the middle, if we go back up and look, we can see it here. It's over here. Is 2x minus 400, right? So we need 2x minus 400 here. So that's going to be 2 times that 600 minus that 400. So that's 1,200 minus 400. So that makes it now 800 feet, doesn't it? Right, a little bit too. Maybe that'll help. There we go. So that piece is 800 feet. We've labeled it. And now we need the longest side. What about the longest side? Well, the longest side is 2 times that 600 minus 200. So that is 1,200 minus 200. So that comes out to be an even 1,000 feet. So there's our three parts. How do we know that we did it correctly? How can we check and make sure that it works? Well, what do we know? We know that these sides should add up together to give me what now? 1,200, okay? If I add these up, do I get my 1,200? Well, let's double check and make sure. We've got 600, right? Add 800, add 1,000. Do we get our 2,400? Yes, we do. So we know we did it correctly, okay? Don't try to make them more complicated than what they need to be. I always like to use words and then put the variables in. I think it makes it a lot easier. And students are less likely to get confused. If you want to just jump straight to the variables, you can do that. However, I think students need to see all the steps written out. Now we're going to move on to the questions everyone struggles with in your previous courses and in this one as well. The mixture, distance, and interest questions. So we're going to start off with the distance questions. And these are, I think, probably the easiest. And this is still in 1-2, and we're going to talk about distance. Now, when we talk about the distance questions, three things can happen. They can add together, okay? They can subtract from each other, or they can equal. We have to draw a diagram with vectors so we can see whether it's addition, subtraction, or if they equal. If they go in opposite directions like this is addition. North, south, east, west, those are addition. And they can even be going towards each other like this. This is addition. Okay, so these are all addition. So if our diagram, if our picture looks like this, it's addition. However, if they overlap, it's subtraction. So people running a race, all right, if they overlap, then you subtract. Okay, so if you have overlap, you're always going to have subtraction. When can they be equal? Well, they can be equal when they're the same. And how can that happen? Well, that can be going home and going to work. If you go home, if you're at home and you go to work, and you go to work and you come back home, those distances should be the what? Same. So these are the three different scenarios that we can have. Addition, subtraction, or equals. Now, what we're going to do is we're going to read our question, we're going to draw a diagram, and then we're going to have to build our equation from the distance formula. So we'll work through a couple of these. These generally are not as difficult as the mixture questions or investments. These are a little bit easier. Only thing you have to be careful of is, again, do they add, subtract, or do they equal each other? So we'll pick out a couple of these from our textbook. And I'm going to be on page 120. And we'll look at question 22. Okay, so first off, we're just going to read through it. Now, don't try to make this more difficult than it really needs to be. We're going to draw a diagram and we're going to label it. The students struggle with these, and I realize that. The more of them that we do, the easier they are. And hopefully you've seen these before, but we really need to make sure we have a refresher here. 22. Two planes leave LA at the same time. One heads south to San Diego, while the other heads north to San Francisco. The San Diego plane flies 50 miles per hour slower than the San Francisco plane. In a half hour, the planes are 275 miles apart. What are their speeds? So the first thing we need to do is figure out whether it's addition, subtraction, or equals. So when we read this one, what does it say? They leave LA at the same time. One goes north to San Diego, one heads south to San Francisco. So they're going to start right here in LA. One goes north, one goes south. So, looking at my picture, addition or subtraction? Which one? Addition, okay? How could it be subtraction? If they overlap, which the next one will be an overlap one. This one is not. Okay, so this is going to be addition. So I know that. And we've got south to San Diego. And north to San Francisco. Now we need to think about distance and what goes into that. And the way I remember it is I think about driving a car. Okay, when I drive a car, there are three things that I keep track of. How long it takes me to get to my destination. So that's our time. Okay? How many miles or kilometers, usually it's miles for us, how many miles did I drive? Right? And how fast am I going? How many miles an hour? So those are the three things. Rate, time, distance. Now, rate times time gives you the distance. So when we work these out, we're going to get the rate, the time, multiply them to get the distance at the end. So we've got our diagram. And now we're going to start labeling it. The San Diego plane flies 50 miles per hour slower than the San Francisco plane. Okay? So the San Diego plane, it says it is 50 miles an hour slower. So its rate of speed is unknown, but we know how it relates to the San Francisco plane. San Diego plane is 50 miles an hour slower. So that's going to be x minus 50. And this San Francisco plane, we don't know its speed, so that's x. Okay? So San Francisco plane, unknown. San Diego plane, 50 miles per hour slower. In a half hour. So what does that half hour represent? Time for both of them. So half hour here and half hour here. So that's our time. Now we've got everything that we need, and it says in a half hour, they are 275 miles apart. So the total distance is 275. So we'll come back to that here in just a moment. Right? So let's review what we've got. We've got our diagram. We know their addition. We need the rate and the time for each one of these so we can get the distance. We know our total distance is 275. How do we find our distance? Well, the distance is the rate times the time. Okay? Rate times time gives you the distance. We've got the San Francisco plane. And what would the San Francisco plane's distance be? Rate times time. So rate times time, that would be 1/2 x. Is everyone okay with that? Those two go together. All you have to remember is multiply. So that's a 1/2 x. Now you can use 0.5. It's not going to matter because it's going to go away anyways. These fractions will cancel. So there's our San Francisco plane. Now what about the San Diego plane? What would it be? Now we have to use parentheses here. Its rate is x minus 50. Its time is a 1/2. So I'm going to say 1/2 times x minus 50. And then this is going to equal the total distance. And what's our total distance? 275. Okay, those are our equations. You can make a table. I don't like to use the table. I think the table is more confusing than just drawing a picture up. Okay, so here's your equation. Now, it shouldn't be a big problem to solve because those fractions are going to cancel. We'll distribute that 1/2 through, and we've got 1/2 x plus 1/2 x. And what's half of 50? Half of 50 is 25. That equals 275. Okay, these can go together. So half and half makes the whole x. I'm going to add the 25 over. And now we've got x equals now what? 300. Okay, so those just went together here. Okay. Draw that so it looks better. So that gives me the x there. Those added together, it gives me my 300. Now, what do we want for the question? We want, make sure we get what we want for the answer. We want both planes. We want the speed of both planes. So let's look at the San Francisco plane. The San Francisco plane is x, and it's 300. Now, this is a speed, right? So this is going to be in what? Can someone tell me? Miles per hour. What would it be in? Miles per hour. Okay, it's a speed. Just remember what you're working with. Use a little bit of common sense. If it's a speed, it's either going to be kilometers an hour or miles per hour, pretty much. It could be meters per second, but normally it's either kilometers an hour or miles an hour. And what about the San Diego plane? Yep. And how did we get that? We have 300, right? Minus that 50. And that gives me now 250. And that is miles per hour. If you wanted to, now you don't have to, if you wanted to, how can you check and make sure it makes sense? Well, let's do a check. If I wanted to check, let's look at the San Francisco plane. San Francisco plane, 300 miles an hour for a half hour. What about the San Diego plane? San Diego plane is 250 miles an hour for a half hour. That should equal 275 miles, right? We did it right. It should work. Okay, half of 300. What's half of 300? 150. Easy enough there. Half of 250 is 125. Okay, and what happens if I add them together? 275 equals 275. So it works. You don't have to check them, but you can. Now again, use common sense. If I would have gotten something like 5,000 miles an hour for that airplane, that's probably not going to be right. The airplanes usually don't, unless it's a supersonic jet or something, doesn't travel that fast. Okay, those seem like legitimate speeds, and so it makes sense. And if you want to, you can always go back and check. And that was an example of when they add together. The next one, they're going to subtract from each other. So the next one is going to be subtraction. And we will look at 23. So we're going to be looking at question 23. In the Apple Hill Fun Run, Mary runs at 7 miles an hour and Janet runs at 5. If they start at the same time, how long will it be before they are 1.5 miles or 1.5 miles apart? They're going to run in a race, and I always like to write the faster one on top. That way I get the order correct. If you put them in the wrong order, you'll just end up with a negative answer. So if you got a negative answer, you just put them backwards. And so we've got two people running here. We've got Mary and we've got Janet. And Mary's traveling faster, so I'm going to put Mary on top, Janet down below. And Mary's rate of speed is 7, and Janet's rate of speed is 5. Do you think this is addition or subtraction? Okay, subtraction. Why is it subtraction? Because they overlap. That's the easiest way to remember. So they overlap, so these are going to subtract. And we also know how far apart they are. So my total distance is given in the question to be what? Can someone tell me? Just so we're on the right page here. How far apart are they at the end? Yep, so that's going to be 1.5 there. Just to make sure we're keeping up here. So that's our 1.5. Now, what part do we not know? We know the distance. We know the rate. Do we know the time? Nope, so that's unknown. So we're going to call the time x for these. Okay, so everyone all right with this so far? Now we're going to move on, and we're going to talk about our distance. Well, our distance is the same each time, and distance is the rate times the time. Okay, so let's work with each one individually. We multiply. So for Mary, and always write the faster one on top. That way you subtract and get the correct sign. If you flip them around, you'll end up with a negative answer, which is okay. You just have to make it positive. But I always like to make sure it's not. So I always like to write the faster person first. So Mary, rate of speed is 7. Time is x. So that's going to be 7x. Now, it's subtraction, right? Why is it subtraction? Because, again, they do what? Overlap. And what about Janet? What is hers? 5 times x, so that is a 5x. And what's the total distance apart? 1.5 or 1.5. Now we're done. We can finish this without any real difficulty. Okay, so I'll put these together. 7x minus 5x, that's a 2x, and that equals 1.5. We'll divide by our 2. And x equals now, what is it, 0.75? And this one has decimals, so I'll let you write it in a variety of different ways. Now, what is x? Let's make sure we know. X is the time, and it's in terms of hours. So, a couple of different ways that we can write it. You could write it as 0.75 hours. That's okay. Or you could write it as 3/4 of an hour. Or you could write it as 45 minutes. All of these are the same. So I don't care which one you write it out as. These are all the same. So I'll take any of them. 0.75 hours. Just make sure you label it. 3/4 of an hour or 45 minutes. They're all the same. I don't care. It doesn't specifically tell us, so any of them are fine. Okay. So it didn't tell us, so I don't care. Is everyone all right with that so far? Does everyone see how those work? Okay. Now let's work with wind. We still have a distance to work with, but what do we know about wind? And if we have a car and we have a wind is either going to speed up that car or that airplane or slow it down. So now we're going to look at 28. And this one's a little bit more challenging. And we're going to have to, again, draw our picture, label it, and work it out. And answer the question. So 28. Now, 27 is boat speed, so it's going to work with currents and boats, or wind and airplanes. Same thing. But we're going to look here at 28. So 28. Okay. Anthony traveled against the wind in a small plane for 3 hours. The return trip took 2.8 hours. Find the speed of the wind to the nearest tenth if the speed of the plane in still air is 180 miles an hour. Okay, so first off, draw our picture. What do we know? Addition, subtraction, or equals. Well, the picture is going to look like this. We're going to go someplace, and then we're going to come back. So what do you think this is going to be? Addition, subtraction, or equals? Okay, equals, right? Because they should be the same, shouldn't they? Right? They should overlap. They should be the same, and if you subtract them, they would be 0. So they were equal. Okay? If it's 5 miles to work, it's 5 miles back home. So we know it's equals. Now we've got to start putting the pieces together. So he traveled against the wind for 3 hours. So this is going to be our wind over here. So Anthony's leaving, and he's traveling against the wind. That means that the wind is going to force him back, right? This is against the wind. We don't know the speed of the wind, so I'm going to use x for that, because that's our unknown part. We don't know the speed of the wind. What about the speed of the plane in still air? Well, the speed of the plane in still air, it tells us this is a prop-driven airplane, so it's pretty slow. The speed of this airplane, the fastest it can go, is 180 by itself. Now, you can add or subtract from it depending upon the wind. So if it's traveling against the wind, then what's its rate of speed going to be? Well, is the wind going to add to it or subtract from it? Look at the way this is going. This is going here. The wind's going to go here. It's traveling against. So what is that going to be? Is that going to be 180 minus x or 180 plus x? Which one? Okay. Look at the way they're going. Yep, you're correct. This is going to force it backwards, right? So this one is going to be 180 minus x. And this one down here, this is with the wind. And what would it be? Its rate would be 180 plus x. So simple enough there. We still need our 3 components. We need the rate, time, to get the distance. So Anthony traveled against the wind in a small plane for 3 hours. So against the wind for 3 hours. So that means this time is 3. With the wind. When he comes back with the wind helping, it's faster, and it's 2.8. So we've got that. And what do we know about the distances here? They should be the same. They should equal each other, right? So the distances are equal. So we've got everything that we need. So let's build our equation. So first, let's look at against the wind. All right, if I'm going against the wind, rate times time. So that is going to be 3 times 180 minus x. With the wind is here, and what is it going to be? And watch your decimal here. It's going to be 2.8 times 180 plus x, right? Is everyone okay with how I got that? Right? Build our equation, and we got it. Now let's finish it. So begin by distributing that 3 through and that 2.8 through. Use a calculator. We've got decimals, so we can use decimals. So 180 times 3, that's 540. Distribute that 3 through, so that's a minus 3x there. 180 times 2.8, well, that's 504, plus 2.8x there. And now we are on the right track. So now we should be able to quickly and easily solve it. So move things around. Be careful with the decimals. Students tend to make mistakes with decimals, so be very, very careful with the decimals. Move that 2.8x over with subtraction, and move that 540 over as well. Watch your signs and be careful. So 3, this is a negative, minus 2.8. They're both negative, so make that still negative, and that's going to be a negative 5.8x. On the left-hand side. Those cancel on the right. And what about on the right-hand side? Well, it's 504 minus 540. So it's going to be, again, negative. And this is a negative 36. We'll divide by our negative 5.8. And that gives me x equaling now 36 divided by 5.8. And we've got decimals. So we'll go ahead and write it out. And what does it say about the answer? Find the speed of the wind to the nearest tenth. Okay, so if I write it out, this is what I've got. Right? If I divide it through, that's what I get. 6.206 goes on forever. But I want it to the nearest tenth. So to the nearest tenth, that will be 6.2. And what do you think the units are going to be? This is the wind. How do we measure wind? What's the speed of the wind? What unit of measure? Do we measure wind in miles? No. We measure it in what? Miles per hour. Okay, so 6.2, that's the wind. Nearest tenth, we've got that. So this is going to be in miles per hour. So the speed of that wind, that's what we wanted, is 6.2 miles per hour. Does everyone all right with those? Does everyone see how that works? Now we're going to move on and we're going to look at the mixture and we're going to look at the investment questions. And we'll do a couple of each one. You've seen these before, but these are the ones that students struggle with. We're still in 1.2. And we're going to look at a mixture question. So page 121. We'll look at question 32. And the mixture ones usually are a little bit easier than the investment ones. Now what we're going to look at is we're going to look at the amount that's in there, and we're going to look at the percentage rate and multiply those just like the distance, but instead of distance we're going to get pure. So amount, rate, and pure. So let's look at 32. How many gallons of pure alcohol must be mixed with 20 gallons of a 15% solution to obtain a mixture that is 25% alcohol? Here's how I like to work these out. I like to draw a diagram. And label. So this is box 1, box 2, and box 3. And I just remember 1 plus 2 is 3. That's the easiest way to remember. Amount and rate. And this is going to be what I start with. And box 3 is the only one that's really important. Box 3 is what you end with or want. So whatever you end with or you want has to go in box 3. So we're going to read it, and we're going to put them in the spots where they belong. How many gallons of pure alcohol? So how many gallons of pure alcohol? First off, do we know how many gallons we have? No. So that means the first one is unknown. And it is pure, so what is the concentration of pure alcohol? As a percent, that rate would be what? That rate would be 100. Is everyone okay with that? And I know you've done a lot of these, but we still need to make sure we're comfortable with them. So we are going to mix that. That means we're going to add to it. What are we going to add to it? 20 gallons of a 15% solution. So that goes here. That's my second. And box number 3 is the really important part. Okay, box number 3 is what we want. We want to obtain a mixture that is 25%. Now, what about my amount? Okay, 1 plus 2 is 3. These add together. So adding them together, that's going to give you x plus 20 then when I add across. Now, most of the work is done. Build our equation. We look now at the pure. Pure is the amount times the rate. And when we work these out, we need to make sure that our percents go to a decimal. So 100%, that's 1. So box number 1 is what we're going to look at. 100% is 1, so that is 1x. You don't have to put the 1 there. I'm just doing it so you see 100% is the 1. What about the second box? Okay, 20 times 0.15. And box 3, what's in box 3? 0.25 times x plus 20. Is everybody okay with how I made that equation? Multiply, put them here. Multiply, put them there. Multiply, put them there. Now we can finish it. Should not take long at all to finish. We'll just multiply and combine. So that's going to be an x, and then we've got 20 times 0.15. That's a 3. So that takes care of that there. And that equals, distribute through. So draw your arrow so you don't make a mistake. Drawing my arrows. That is 0.25x. And 0.25 times 20. And that should be a 5, I believe. We're going to go ahead and solve this out. And I'm going to write this as 1.0x. That way we don't make a mistake with the decimal. Because students tend to make mistakes with the decimals if we're not really, really careful. I'm going to move that over. And I'm going to move the 3 over as well. So 1 minus 0.25. Well, that is 0.75x. The 3's cancel, right? 0.25x's cancel. And 5 minus 3, well, that's a 2. We'll divide by our 0.75. And now we've got it. And so 2, divide that by 0.75. That gives me, it doesn't say how far to round, does it? Let's see here. No, it doesn't. Okay, it doesn't tell us at all. You can use a decimal or you can use a fraction. I don't care. They wrote it as a fraction. We'll just use a decimal, and we'll take this out to 3 places. So close enough. And this is 2.66. We'll round 7. And this is going to be in terms of, it's an amount. So this is in terms of gallons, okay, of pure. So what do we need? We need 2.667 gallons of pure, 100%. And you could write this as, if you wanted, 2 2/3 gallons, either one. They're the same. So I would take either one. Most of you are probably going to use the decimal, but that's okay. These are the same. So I would take either one. You can write it as 2 2/3, or you can write it as 2.667 gallons. Same thing. I don't care. Whenever you have decimals, use decimals. If you don't have decimals, you've got to keep the fractions. But this one gave us decimals to begin with when we made the percentages, so we can use decimals. Okay, let's try another one. Let's do an interest one now. Interest is very, very similar to investment. It's almost identical. Let's look at 38. Now, investment and mixtures are pretty much the same. Only difference is, instead of it being pure, it's interest. That's it. But they're labeled the same. And instead of drawing a little picture of a container, I use a dollar sign. So 38. We should have enough time to hopefully do 2 of these. Question 38. Investing in a church fund. We're going to read it, and we're going to work it through. A church building fund has invested some money in 2 ways. Part of it at 3%, 4 times as much at 2.75%. Find the amount invested at each rate if the total annual income is $2,800. Okay, so we're going to look here at this. Let's see what we've got. We've got our dollar signs here. First one and second one. Just like we did before, amount and rate. So we're investing in this church building fund, and it says we invested some money at 3%. So we don't know how much, so we'll use an X, and my percentage rate is 3%. And I always like to add these up to get my total amount over here too. Okay, so first one is X, and we put that in a 3% fund. And 4 times as much, well, that would be 4X. And 4X is going to be at, where is it here? 4 times as much at 2.75%. Adding those together, because these add across, that's 5X. Now that's the amount, not the interest. Now we're going to find our interest. And the interest is the amount times the rate. First one, amount times the rate. Well, that is 0.03 times X. Next one is 0.275 times your 4X there. And this is interest, so over here, we need our total interest earned. And how much total interest did we make? Putting these together, we made a total of $2,800. Now, when we talk about interest, here's how I like to explain it. Simple savings account. If you have a savings account at the bank, you get a statement in the mail. What does it say? Percentage rate that it paid out, like the 1 or 2% that it paid out in interest. It tells you how much money you had in there. So let's say you had $5,000, okay? So it'll say $5,000, and then it'll say interest. And you might have only made $5 in interest, but that's what it'll have. Amount of money, so that's how much is in it, $5,000, let's say, for example. Let's say it pays 1 or 2%, okay? And then they say they give you the $5 in interest. So amount, rate, multiply them together to get the interest. Now we can finish it. So take your time and distribute through and solve. So that's going to be 0.03x plus, we've got 4 times 0.275, and that comes out to be 1.1x there. And that equals your, watch out, make sure you got enough decimals here. I just about forgot, that should be 0.0275. Make sure you have the correct number of zeros. It's so easy to make a mistake with these decimals. So let's try that again. So easy to make a mistake here. And that's going to be 0.11x. Sorry about that. But again, it's easy to do. Make sure you have the correct number of zeros with these percentages. And that equals your 2,800. Add them together. So these are the same. They can go together. And that gives you 0.14x equals your 2,800. Divide by the 0.14. And that now leaves me with x equaling what? 2,800. Divide that by 0.14. And if we did it correctly, these normally come out to be whole numbers. So that gives you now 20,000. We want how much is in each fund. So we want to find the amount in each fund. So we just plug the numbers in. 3%. What went with 3%? X. So X was 20,000. So we have $20,000 at 3%. There's the first one. What about the other one? 4x here. Okay. We don't need the 5x, but I put it here because sometimes students want to put the 2,800 here. And it's not. It goes down here. So that's why I put the 5x there. But what we're looking at is this one. So that's going to be 4 times your 20,000. And that gives you $60,000 at 2.75%. And that's what we've got. And you could check it. We're kind of short on time, so I'm not going to. But those are your two answers. So 20,000 and 60,000. Or not 60,000, 80,000. My mistake. Not multiplying correct here. Sorry about that. Should be 80,000 because 4 times 20,000 makes it 80,000. So 20,000 and 80,000. Okay. And we've got enough time, I think, for one more. Let's do one more, and this will be our last one. And I'll go ahead and pass out the sign-in sheet. And we'll do one more question, and then we'll talk about our homework. Okay, so one more of these, and let's look at question 40. Okay, we should have enough time, I think, to get through question 40. Okay, so question 40. Becky earned $48,000 from royalties on her cookbook. Okay, she paid 28% income tax on those royalties, and the balance was invested in two ways. Some of it at 3.25% and some of it at 1.75%. They produced $904.80 total. Find the amount invested at each rate. Okay, well, let's start off with the $48,000. We don't invest that $48,000. How much do we actually have to invest? Well, we've got $48,000. The tax rate is 28%. So let's find our taxes. To find our taxes, we've got our $48,000 times 0.28. So that means how much money we actually have to invest. We'll have to multiply here and subtract off. Okay, we've got $13,440. This is your taxes. So how much do we have to invest? Well, to invest, we've got $48,000. Take away that $13,440, and that gives us then a difference of $34,560. So that's how much money that we have to invest. Now, what's our equation going to look like? Well, it's going to go back again to investments with the dollar signs. Where does that $34.56 go to? That goes over here, and this is my total amount. So this is going to be my total amount here. So this one is a little bit different from the last one. Not a lot, but just a little bit different. Okay, so we've got this $34,560 that we're going to put in the bank. And we're going to invest it in two different accounts. Maybe CDs and bonds, whatever it might be. One of them is at 3.25%. And the other one is at 1.75%. Now, here's the difference between this one and the last one. Do I know how much money I have at the 3.25%? Do we know that at all? No. Okay, so what are we going to use here? We don't know, so we use an X. Okay. And we can't use the X again, so this one is going to be the total minus X. So this one is going to be $43,560 minus X there. Because they have to add together to give you this $34,560. One's got a positive X, a negative X, and they cancel out. So if you don't know either one of them, you call the first one X. The second one is the total minus X. Now, I'm going to build the equation, and you can finish it if you want to. But we're going to at least build the equation. And the interest is the amount times the rate. So amount times the rate is the interest. And let's work this out. On our first one, excuse me, we've got 3.25%, so that's 0.0325 times X. That's that piece. The second one is 0.0175 times 34,560 minus X. And then over here, well, this is the total interest, not the amount. The total interest that I made, which is $900. and $4.80. And I think you can finish this on your own. Now, I do want to look at one quick question real fast out of the homework. And I only gave you 2 of these, and these are the simplest ones to do. And then that'll be it for today. So I want to look at one quick question from your homework. So homework 1.2, let's look at question 4. We should be finishing right on time, a few minutes early. Okay. There's 2 of these in your homework. All I want you to do on these is plug the values in. So we're looking at a model. So your home state uses a linear model right here to predict the number of vacationers, Y, compared to the average temperature for the week. Find the number of vacationers predicted for a week with an average of 53 degrees. So let's write up our equation and plug our number in. So what's our equation? Our equation is Y equals 43 times X minus 70 plus 43, 24. X is represented by the temp that week. Y is the vacationers. What we want is we want the temperature on this particular week to be 53 degrees. So we're going to plug in to 53. That's it. And this should tell us how many vacationers that we should expect to get that week. That's all I want you to do on this one, is understand how to label and plug the value in. So just plug it in, work it out. Okay, so we have 53 minus the 70. That's a minus 17. 43, 24. Multiply those together. So 43 times a negative 17. That's a minus 731. Plus 43, 24. And we simply put those together. And we now have 43, 24 minus 731. That gives me now 3,593. And these are going to be vacationers. Okay, so that's going to be your answer on that one. Now let's quickly talk about our homework. .1 we did last time. Okay? 1.1, I want you to turn this in on Tuesday. This way I have something to start recording in your gradebook. So on Tuesday, all I want you to do is turn in 1.1. Now, you should also be able to work through 1.2. So you can work 1.2 out. You can work this one out. I'm not going to pick it up on Tuesday because I figure you'll probably need to go back and rework some of them. But on Tuesday, I'll just have you separate that 1.1 out of your packet and turn that in. That way I can start collecting homework and get grades in your Canvas course. So 1.1, turn that in on Tuesday. There's not much to it. You probably already have it done, but go ahead and start working on 1.2. On Tuesday, we're going to go through questions out of 1.2. And I assume we'll probably have a lot, and then we'll cover 1.3. Also, please make sure that you sign that sign-in sheet. So before you leave, please make sure you sign the sign-in sheet if you haven't done so.